Hello, everyone, and welcome to our What's New in SAP HANA Cloud for Q4 webinar. My name is Andrea, and I'm part of the product management team for SAP HANA Cloud. Today, we're very excited to give you a deep dive into some of the great features which will be introduced with our QRC4 release. But as always, we will unfortunately not have enough time to cover all of the topics or all of the scope of our last release for this year. But we will give you an overview of the most important innovations that we have been delivered. If you're looking for a complete breakdown, I definitely recommend checking out our upcoming What's New blog post and the technical documentation. You will also hear from several of my product management colleagues today who are here with me right now and who will provide deeper insight into their specific areas of expertise. So going forward, we can check the agenda, and today I will give a general update, and then Dan is going to deep dive into the updates to SAP HANA Cloud tooling. Christoph will give us a detailed explanation of the multimodal and machine learning updates, and Jan will be speaking about the calculation view modeling updates. Then Ralph will explain about the multi-region disaster recovery, active-active, automated storage scaling, and Rob will go then with the consuming data products, with how to consume data products from SAP Business Data Cloud. And at the end, in June, we'll speak about the SQL files, Delta table, replication into SAP HANA Cloud. So let's go through the general updates of some of our new innovations. I will begin with a powerful enhancement on the native multi-tenancy capabilities in SAP HANA Cloud. So what's new about this? We now support tenant moves with near zero downtime within a data center. Previously, moving a tenant between HANA Cloud instances meant extended downtime. With this innovation, the move is now split into two distinct phases. So during the preparation phase, this is the longer phase. The tenant data is copied from the source to the target instance while the original tenant remains fully available. There is no business downtime during this phase. And during the cut-over phase, this is a short control phase. The original tenant is briefly disconnected, final delta changes are applied, and the target tenant is enabled for application use. This is the only point where business downtime occurs, and it's significantly reduced. Why does it matter to you? The downtime is reduced to a short, predictable window. You can separately trigger preparation and cut over using tenant management service API calls. And this allows the cutover to be scheduled during low impact time windows. The preparation phase can run as long as needed before final execution. And overall, this gives you much more control, flexibility, and operational confidence when managing tenant moves. We're introducing the SAP HANA Cloud availability in 6 new SAP BTP regions. Italy on Amazon Web Services, Germany on SAP HANA Cloud Infrastructure, the United Arab Emirates on SAP HANA Cloud Infrastructure, the US West on SAP Cloud Infrastructure, Japan on SAP Cloud Infrastructure, and Australia on SAP Cloud Infrastructure. With Italy on Amazon Web Services, we now have a second European Amazon Web Service region, establishing the foundation now for our multi-region disaster recovery within Europe. And following the first SAP Cloud Infrastructure region in Germany announced in Q3, we are now expanding SAP Cloud Infrastructure globally, including regions in the US, Australia, Japan, and the United Arab Emirates. Now let's move to innovations enhancing database migration. So what's new here? We now support selective incremental migration for HANA Cloud 2.0 on-premise to SAP HANA Cloud. Instead of migrating an entire database at once, you can now migrate selected parts of a source database, divide migration into multiple smaller migration processes, and migrate subset one after another. This applies to full database migrations or selective migrations based on excess managed containers, plain SQL schemas. And this capability delivers several key advantages. So you can migrate not only what is needed, omitting unused or obsolete data. Large databases can be migrated in manageable parts. Smaller migration scopes mean shorter downtime windows, and the migration becomes more flexible, predictable, and lower risk. So overall, this significantly lowers the barrier for moving complex, large-scale HANA systems to the cloud. Following, we have performance optimization with the new rule-based index advisor. What does it do? The rule-based index advisor analyzes your SAP Cloud instance, identifies indexing opportunities using predefined rules, and focuses on query usage patterns, especially single table filter queries. So based on this analysis, it recommends creating or dropping indexes, helps improve query performance, and supports cost optimization. Importantly, the advisor provides ready-to-execute SQL statements, making it easy to act on each recommendation. The current scope and limitations are to set expectations that the joint queries are not yet supported, vector and spatial columns are not analyzed, and objects in tenants are currently out of scope. But for sure, we will continue extending the capabilities of the advisor, making it an even more powerful tool in the future. And with that, I will hand it over to Dan, who is covering the SQL tools for administration in SAP HANA Cloud Central.
Thank you, Andrea. Yes, so my name is Dan Van Leeuwen, and I'll be covering some of these SQL tools and some new additions within SAP HANA Cloud Central. And the first one that I want to take a look at is that we've introduced a new application within HANA Cloud Central to view the schemas and HDI containers. But first, before I show that, I just wanted to kind of put this into context. So here I've got within the SAP BTP cockpit, I've got a couple of SAP HANA Cloud instances and 3 different HDI containers. And if I go now to HANA Cloud Central, I can see that I now have a new application called Schemas and HDI Containers, where I can see my list of different HDI containers that are grouped according to their database instance that they're associated with. I can also see additional information such as what Cloud Foundry space that they belong to. And through the Actions menu, I can choose to open a SQL console to the parent or the associated database. I can explore the associated instances in the instances overview page, or I can jump to the SAP HANA Database Explorer so that I'm able to directly connect to that HDI container and view more information that way. Okay, next up, I'd like to talk about a new feature in the Database Objects app. So this is related to property graphs. We now have a viewer that allows you to visually explore your property graphs. So in this case here, I've got a property graph that is based on a set of vertexes or edges, vertexes and nodes, and then the edges that connect them. And in this case, if you were to, for example, click on a particular vertex, you can see the properties would show up, and you can see the information about the particular hotel that you're clicking on. And if you were to click on the edge that joins the 2 nodes, you can see information about, for example, what is the distance between the 2 nodes. In the viewer, there is a filter so that if you wanted to narrow down your graph, which is what's shown here on the screen, to maybe just show me the nodes or the hotels that are within the state of Florida. You can also click on the algorithms menu item here, and there's different built-in algorithms that you can use. So if you had a more complex graph, you might want to determine what is the shortest path from one node to the next, or from one node to another node. There's also a neighborhood algorithm, which allows you to, for example, select a particular node and say, I only want to view the nodes that are maybe have 3 connections from the particular node that I'm on, that I've selected. As well as there's the cipher algorithm, so you can write an open cipher query to do pattern matching to just select certain nodes that you want to view. Okay, jumping into the SQL console. One of the new features here is the ability to now have your contents of your SQL consoles auto-save. So this is very helpful if, for example, you need to do a reboot, or you're maybe shutting down on one computer and you're opening up on another computer. Then when you log into the HANA Cloud Central and go to your SQL console, you'll have all of your different SQL consoles that you've currently been working on. So the last one that you connected the last one that you've been working with will load up, be selected, and connected to the particular database that you were last working on, which is very helpful. And this is a configurable option, so it can be turned on and off through the settings, through the auto-save contents of SQL consoles. Another new feature within the SQL console is the ability to run statements in the background. So this would be helpful if you are running a long query and maybe the network that you're on, maybe it's not very stable. You can choose to run the statement in the background, and then you can disconnect, come back into the office tomorrow or the next day, and look at the results of your SQL query that you've previously ran that's been maybe running in the background. So to do so, you would click on the background statements to view the results, and then in the actions menu, you could choose to open that particular run of that statement and see the details of it. Okay, and then the final option that I wanted to highlight here is that we're trying to make it a little bit easier now to jump from within your SQL console to your database objects app, which will show you more details about your tables and views, functions, procedures that you're using. So in this case, if you open up the syntax help, it'll show details here about the contents of your SQL query. So what tables, for example, that you're using, and it's now a clickable link so that you can jump directly to the database objects app and see more details about a particular table that's in your SQL query. Okay, so that quickly went over some of the highlights of some of the new features around SQL tools within HANA Cloud Central. And with that, I'd like to pass it over to my colleague, Christoph, who will talk about multimodal and machine learning.
Thank you very much, Dan. Yes, and again, for also the topic area of the AI capabilities in the HANA Cloud, we have a nice set of new enhancements. We're starting off with an enhancement in the graph area. As you know, we've had the property graph, and we've also just saw the graph viewer, which Dan showcased. And in Q1 this year, we introduced the knowledge graph engine for storing triples type of graphs using the graph engine. And certainly many customers asked for conversion capabilities from those property graphs also into the new knowledge graph engine triple graphs. And for that, we're providing a new procedure which makes it really easy to basically reference to the graph workspace from the property graph. And with that, then the vertices will be converted into triple, and the edges as in their properties will be kind of converted to kind of extended embedded triples, so it will not be flattened out to the triple objects, but kind of connected as a real graph within to the structure. But it's a pretty nice procedure, and there's different modes how to make use of it, using an auto mode, mapping only to validate kind of what will the graph look like, ignore errors maybe of things which cannot be mapped over, or have a strict enforced way of using the procedure to ensure that we only convert if we can convert everything. And certainly all the features of the new graph engine can be used, like the Sparkle engine, for querying the new graph engine graph. Let's look at the machine learning and natural language processing services capabilities. The predictive analysis library provides, again, a rich set of new functions, like a new unified time series functional interface, where multiple of the time series algorithms can be now used through one interface, making it much easier for application developers to also switch between different algorithms as the interface into the application stays the same. For AutoML, we have a couple of capabilities enhanced, like prediction intervals for time series AutoML models. And a key highlight in this release is that we can feed into raw text columns into our AutoML models for classification and regression scenarios. We will see that in a second in more detail as the next two items as well. Our text embedding models have been enhanced with the capability to reduce the vector size of the output dimensions of the embedding. A new cross-encoder model is introduced as part of the NLP services, making it, or providing a helpful function to re-rank vector engine search results for even higher accurate search results or hybrid search results. And then on the text pre-processing side, there are new functions to detect log patterns from log text, which you would process with these functions. And as you run it, you can detect new log types and flavors, helping it to kind of reduce and identify duplicates in the logs you are processing with that application. In the same context, the text tokenization function is enriched with a regular expression filter, so you can filter out from the identified tokens which you want to keep or which you want to drop from the token string. And then the HANA tracking, experiment tracking and schedule management feature also is enhanced with one really nice capability like the experiment monitor, which allows to specify on the one side custom tags and metadata with the experiments you have been pursuing or executing. And secondly, the experiment monitor in the HANA ML client also adds a model monitoring and model drift capability. So let's explore some of these features in more details. The two text embedding models which we provide out of HANA Cloud have been enriched with an attached linear layer for reduction of the output vector size. Its dimensionality, the standard dimensionality of the text embedding models in HANA Cloud is 768. And with this new added neural network layer of the models, you can reduce this vector size or the dimension of the vector while keeping nearly the same retrieval task accuracy when you use it for retrieval tasks or for machine learning tasks where you make use of embedding vectors of your textual data. As an example, if we reduce the vector dimensionality from 768 to 256, we reduce the vector size by to a third, but we keep almost the same accuracy when running retrieval queries against those vectors. So a great enhancement, providing speed and lower resource consumptions when making use of vectors with a minimal information loss. Great new feature in the Q4 release. The second one is then certainly, as I called it out already, the use of text data with AutoML models or AutoML pipelines. Previously, we had to prepare the vector data and feed the vector data into the AutoML pipeline. Now we can just use the text column, feed it in, and the pipeline itself, the AutoML pipeline, holds a text embedding operator, which then does automatically the magic as part of the data preparation for training a classification or regression model. And then for the users who build AutoML time series models, one gap which we still had in the forecast predictions was that the AutoML time series pipelines did not provide the prediction intervals, which we've now added also to the prediction functions there, then providing the confidence bands as output here to such predictions as well. So kind of a key gap closer there for time series models. But really our release highlight is the cross-encoder model, basically a peer model to our text embedding model, as it allows to process pairs or sets of text like the query statement and result sets from a vector similarity search, which is passed in as a set of information, the query and the search result set into the cross-encoder model is then pre-processed together. And by that, the context of similarity between the query and the pre-ranked search results can be more accurately identified, and therefore the results of these cross-encoder functions is typically providing a higher precision of as compared to the original vector engine search results. And this cross-encoder certainly then also offers the opportunity to maybe have a query, but have result sets from different query scenarios using vector similarity search, but maybe all classic text search results, merging them together, passing that together into the cross-encoder, and then providing a single re-ranked result set across different search query types. And in that context, just to illustrate of retrieval augmented generation applications, where we have business data which is run through a text embedding model stored via the vector engine, a query comes in, which is supposed to be passed to the large language model. The vector engine is called for relevant content. The vector engine, using the similarity search function, provides then the top K retrieved documents. And these results, together with the query, are then run again through the cross-encoder model for a re-ranked list of context of higher precision, which is then passed on to the large language model. So both really work together in sequence, classic vector similarity search and the re-ranking. If you want to look at the function, the cross-encoder functions at this stage, it's a PAL function called PAL_cross-encoder. We basically just provide the model reference with the call, and then feed in the query as a column, the text for similarity, the search results as the other column, and then we get a search result, which is then re-ranked with an improved accurate search result set. And then finally, for the Python machine learning client, there's again a series of enhancements, and all the enhancements are here provided also with a demo in our sample store, which is linked here, but will also be linked in the blog post. And the enhancements include, in the area of time series, the unified time series methods is also provided here in the Python interface. The time series outlier detection provides threshold support for even better kind of detection of outliers, and the prediction interval support, which we just saw for AutoML models, is certainly also immediately available in the Python interface. Also the same for the text data processing and AutoML models and pipelines that can be directly leveraged here also from the Python interface, as we see it on the right-hand side, where we configure an AutoML classification model, specify a feature column called secret text, and flag it as a text variable that basically triggers then the text embedding operator of the AutoML engine to process that data respectively. Other function enhancements include the UMET functions and the pairwise distance functions, which we introduced in the QSE 3 release, which are now also available with the Python interface. Really nice enhancement, as well as the core set sampling for support vector machine models, helping for faster processing times when building support vector machine models. And last one, maybe the experiment monitor, supporting model monitoring or model drift analysis. So overall, again, a really rich set of enhancements, and I'm looking forward for sharing this with you in a blog post, and looking forward to all your comments as well. Thank you. And with that, I'm passing over to Jan.
Thank you very much, Christoph, and hello, everybody. As usual, I will talk about innovations of calculation views. And as also usual, because of the high integration of calculation views with other technologies, I will also share news about the NDS Cube as it can be used together with calculation views. So the first innovation that I want to talk about is the column key indicator. The idea here is that if you're modeling a join, you often are asking yourself probably what are the right columns to join on. And with the key column indicator, we hope to make your decision a little bit easier and give you more insights into the structure of the data. What we do is we display the icon for key columns so that you can, for example, in this example, already see if you join one key column with only one part of another key, because you have two key columns here, then obviously the cardinality cannot be, or probably is not 1, but rather n. So with that, you can, on the one hand side, decide about which columns to use for the join, but also the cardinality. How this key column information is retrieved is depending on what's your data source. If your data source is a table, then it's taken from the primary key definition of the table. If the data source is a calculation view, then this information is taken from the semantics node. The next innovation is about column pruning. And for those of you who are working longer with calculation views, probably are aware of the instantiation behavior. For the other ones, just in a very short version, if you have a view defined on multiple columns and your query only requests a certain subset of it, then what we do in calculation engine per default is that we prune away all columns that are not required for answering the query. So for example, even if you have 100 columns in your calculation view, but you request only one attribute with your measure, then we only process this attribute. Of course, if it's a calculated attribute and it's depending on other columns, we also process them. But the main message is we try to restrict it to the minimum of columns to process. And this behavior is different from what you typically see with SQL views, because with SQL views, if you have some measure applications like average or something like that, then the individual columns that are defined in a view are processed. Now, as said, per default, we offer this column pruning behavior of the calculation views, but we also give options to modify this behavior, and this is done by the keep flag. So you can set a keep flag for a column, which means even if this column is not required by the query, you can still have this column in your aggregation. And that can be wanted. For example, if you want to do an aggregation per country, then even if you don't ask for country, it might be interesting for you to have it aggregated at that level first. Now, as I said, you can modify this behavior with a keep flag, but we wanted to make it also a little bit easier to switch between the different behaviors. So we offer now a drop-down option where you can select between column pruning behavior of the calculation view. On means the default behavior, and you can set it to off, which means we have a keep flag then for all attributes, which also means then that even if you request only one column, every other column will be processed as well till this level. And that can help you to mimic the behavior of SQL views. But you should also be aware that this, of course, means you process a lot of more columns, which can have an influence on the one hand side on the performance and resource consumption, but on the other side also on the semantics of it. Because if you in your reporting client, for example, only ask for one attribute, it might be a little bit surprising if somewhere an aggregation happens still on other columns, simply because that you don't see from your client application because they're hidden, so to say, in the model. And only because in the model there are some keep flags set that you still aggregate on this level. So treat that with care. And our general recommendation is to keep it on the default behavior. But if you want to mimic SQL behavior, or you just want to change or want to compare the behaviors, then there's an easy way now to do so. We also have improved about the insight into your model, and this is about the lineage functionality. We have two functionalities here. One is, and we should not mix that because it's a little bit different. The one is about data lineage and impact analysis. So data lineage means if I have a calculation view, and here's in green one, the calculation view, and if I ask for data lineage of it, then I see what other objects are contributing into this calculation view. The other direction is the impact analysis. So I start here with this calculation view, and I'm asking which other objects are using this calculation view. What I will talk later then is about column lineage. Here we only talk about object lineage. So you see here where these objects are coming from, or where the data here is coming from which objects. Now, what you can do here is you can right-click on the included objects and open them in the editor so that you can better understand what are the objects that are involved in your calculation view. The opening in the editor works as long as the object is in the same HDI container. Without the same HDI container, we don't have access to the design time file, so we also cannot show it. But for objects within your HDI container, you have now the option to investigate them in more details. The second part of the lineage improvements is about column dependencies. And here the question is a little bit different or a little bit more detailed. It's not about what objects are involved, but also, in addition, what columns are involved that contribute to my column. So, for example, if you have a certain amount measure and you want to know which columns contributed to this amount, then this is the way how you can answer that. We provide here an SQL function, get calc_view column dependencies, and you call it with a schema name, the calculation view name, and either the column name that you're interested in, or you keep it as an empty string, then you get it for all columns. And then we have options. At the moment, we only support the base option, which means you see only the very base objects. So meaning if you ask for a certain column, you see what base objects are involved in it and which columns contribute to the individual column that you selected here in your view call. Now, for the MDS functionality, we introduced a new option about to keep the MDS cube also during deployment. And the background is that in the past, often, if a calculation view was redeployed, and that could also be because of an underlying calculation view that was deployed with its dependencies, that the MDS cube data was lost during that. And that's the reason, because if we redeploy a calculation view, the MDS cube is also redeployed, and so loaded data is lost. Now we introduce this keep flag or this keep MDS cube during deployment flag, which means we make sure that even if you deploy the calculation view, that the MDS cube data is kept. Now, you might ask, what happens now if you deploy a calculation view? Can that at all happen? Yes, we allow still to deploy the calculation view, but if the deployment of a change calculation view would lead to an MDS cube that cannot be loaded anymore, then we stop the deployment, which means the MDS cube will be untouched. So you can be sure that you can report on it still as continue to report on it and also load into it. Now, if you change a calculation view in a way that makes the MDS cube not loadable anymore, like for example, you remove a column from the calculation view that's required by the MDS cube, then we stop the deployment. While this flag is set, you cannot edit the MDS cubes anymore. So if you want to edit MDS cubes, you would have to unset the flag, and then you can edit it again. And the final information about MDS cubes is that we support now additional options like the input parameters as client values in the currency conversion, unit conversion, And we support left outer in joins, in start joins, and also restricted columns. Here, we don't support all expressions, but if an expression is not supported by the NDSQ, then you will be notified about it during the deployment. With that, thanks for your attention, and I hand over to Ralf.
Thanks a lot. And welcome. So I now would like to go a little bit down to the earth and talk about our further developments in the multi-region disaster recovery journey. We already released last time the US region, 2 data centers over there. Now the next steps is into the European Union. As you can see in the middle of the slide, we now offer Frankfurt and Milan in Italy as 2 important new coupled regions. So with that, we have a long distance asynchronous replication also in Europe. First implementation here is with AWS. Others will follow for sure. We are here in preparation. So we want to gain higher resilience, of course, for global disasters. We want to increase resiliency via seamless combination with synchronous replication. As you can see on the right side, you can combine our multi-region disaster recovery also with local multi-zone HA and with local HA in the same availability zone. Yeah, the long distance multi-region disaster recovery will accomplish the picture here. So as mentioned, focus right now here in this release is European Union. The rest of the delivery scope is mostly the same. We start with Amazon Web Service. We want to support the couple between EU10 in Frankfurt and EU13 in Milan. We want to support also data lake files. What is still out of focus is native multi-tenancy, but it's also on the roadmap. We are in the preparation, and hopefully during the next quarters you will see advancements here. Setup is still done with the API, so you can maintain the whole thing with the API calls. The UI is also in preparation. I hope beginning of next year we will see first results on the UI side, so that you can do that what's right now available on API level also on the UI. These are short-term restrictions, and please watch out for our roadmap. There we will also release and announce the next steps in this very important endeavor. That said, there is the next item here, active read enabled. It's another very important next move here to give customers more reach with their setups. You know, many customers need high availability options simply because out of obligations. And now we make this whole situation much more affordable to them, because we now allow to run certain workloads on this active high available replica. Like you see on the right side on the picture, we have here the client, which is connected as usual to the source system in the source. Here we have a read-write interaction, of course. From there, the client can send in a statement, SQL statement. This SQL statement has a hint included, and with this hint, we can do a hint-based statement routing and route certain important load intense SQL statements to the replica, and from the replica the communication again goes directly to the client and gives these read enabled pieces back to the client. This is right now planned for an HA setup with synchronous replication. We will, like with the multi-region disaster recovery. Also, this feature has a long endeavor. It's the first step here. The hint-based statement routing was majorly demanded from stakeholders and customers. So we started with that, and we will continue with the next quarters to extend the reach and the capabilities of this feature. So most of the benefits I already mentioned. Of course, we would like to use the additional hardware for the replica for additional performance. We want to reduce the TCO overall because you can make use of the replica. Usage allows to have an additional analytical workload. And yeah, we also will introduce a workload class mapping for the replica, which is a major difference for the on-premise solution you might have used in the past, on-premise active read enabled. Now we also here in HANA Cloud offer active, and we even extended with a workload class mapping on this replica, which is very important. Another important piece is we are activating this without extra charging. So we think this is such an important feature that you really should make use of it if you have a replica running because of obligations, you know. And another very important feature is, information is that you need a new client, at least the version 2.27 or 2.27. As you can see here, the package name makes it easier, hopefully, for you to find it in the download center to have this detail. And as said, this is a long endeavor. Please check out our Roadmap Explorer for the next major milestones. I hope in Q1 we will be able to release the next big steps, like, for example, connection routing, what you probably also know from HANA on-prem, which is often used for data exports. And further down the road, we also want to make this whole solution much easier to use. And let's get surprised what we have here in plan and want to deliver over time. Last one, automatic upscaling storage. You might have had a situation in the past that wherever, probably because you loaded more and more data into your database, that the storage of the database was filled up very quickly and could even cause downtimes because the whole database got stuck and all kinds of follow-up activities or situations could happen. So with QRC4, we are introducing a first version of the auto upscaling storage to prevent exactly these stuck situations as far as possible. In a way that we ask you as an administrator, when you install an instance, when you define the storage size, as shown here in the small picture, there's a new chapter or a section that you can also activate an auto storage upsizing. And this auto storage upsizing can then, there you can give the maximum size. Typically, right now in this early version, it's coupled and doubled from the storage which is already existing. And with that, you still have control about this feature. It's not extending in some kind of an escalation way, but it is only doubling so that you have still control about what's happening here. So if you then consumed also this doubled value, so here in this example, 200 gigabytes to 400 gigabytes, then you reach 400 gigabytes, you would need to go again into the configuration wizard in HANA Cloud Central and then increase the standard size of the instance. And then you get the possibility again to uprise the maximum allowance to then the double value. This keeps you always in the driver's seat. You always know how the cost side could develop here on that side. It's a little bit more manual work, but at the end, I hope you benefit from this higher control for this whole option. Please take care that we have a limitation, not from us, from our cloud service providers, that this change can only do once every 6 hours. It's, as I said, it's not an SAP limit. It's coming right direct from our cloud service providers, and accordingly we have to mention it here. So just as a FAQ, if you have a system which you used for quite some time, you did a lot of testing on top, so you extended it more and more with more memory, more vCPU maybe, and of course the disk will also, the storage will also increase accordingly. And then you would like to, after the project was done, you would like to shrink the storage. The best way to do it is either to drop the instance and create simply a new one. You know, we are here in the cloud, and with the cloud you have this freedom all the time. Or you could recreate the instance, because you said, I have a certain set of data I would like to have in these instances. Then you could recreate the database instance, and with that you could shrink the storage back to the expected sizes. So this is an easy way to go forward. Roadmap here is again also to make this feature more flexible, give more factors, so not only a doubling of the size, but maybe a more fine grain, give higher maximum limits, and so on. But for now, we have a solution here which might look simple, but at the end, with the next step, we want to extend it further down the road. With that said, I would like to hand over to Rob. Please, Rob.
Thanks, Rob. So I get to talk about our ability to consume data products into HANA Cloud from BDC. Make sure I page down in the right spot. So folks probably heard a lot about data products being published through BDC, through the BDC catalog. In supporting the consumption of data products into HANA Cloud, what we're enabling is the building of clean core and extension applications on HANA Cloud, using all of the HANA Cloud advanced analytics capabilities that we talk about, including in this session, and building CAP applications on top of those data products and combining them with your own additional data products for your enterprise. Right? So seamless consumption of the data products, unlocking the value across both the transactional and analytical workloads. And because we're dealing with data products, we're building on the governed data that we're getting from the other SAP applications. The way this works is we start off in BDC Cockpit. And in BDC Cockpit, we have, sorry about that, we have a couple things. One is the formations. So we start by adding our HANA Cloud system to a formation with the producers of the data products we want to consume. So in this case, we add HANA Cloud to a formation with S4. Still in BDC Cockpit, we go to the catalog, this icon here, and we go to the data products tab. All right. Here I filter data products to the data products produced from that S4 system. I can choose one and install it into my HANA Cloud instance. Sorry, rather share it to my HANA Cloud instance. So at this point, the BDC admin is in control of what data products get shared to the HANA Cloud instance. And it is as simple as point and click and share. Moving over to HANA Cloud Central now, if I go to the overview page for a given HANA instance, we now have an additional tab available to us, which is our Data Products tab. Moving to that Data Products tab, we see the list of data products that have been shared to this HANA Cloud instance. And we'll see the status if they have been installed, such as the customer one, if they're available and not yet installed, such as a company code or sales contract. For the installed data products, we also see what schema has been created within the HANA database where these data products are present. If I click on any one of these data products, I can see the available objects within it. So I can see the metadata of what I'm going to be consuming in this data product. To install a data product, I select it And again, it's point and click to install that data product into HANA Cloud. What happens when I install that data product is I get a schema created and I get a set of virtual tables created. So one virtual table for each data source in that data product. Right? And from there, all of my additional HANA Cloud Central DBX capabilities are available. So I can go to the database object viewer. I can see the column details for that data product. As I said, these are installed as virtual table connections in your HANA Cloud HANA database. And you can then use those virtual tables in any SQL query that you want. You can also map them to an HDI tenant using the HDB synonym artifacts. And from there, then, of course, consume them in a CAP application. So it's a really big feature that fully provides full integration in terms of consuming data from BDC in HANA Cloud, fully supporting the clean core building of extension applications. But it's also a really straightforward feature for you, which I really like. Really simple to install. And once they're just tables for you in HANA Cloud. And with that, I will hand it off to Sungjin.
Thank you, Rob. So yeah, as briefly introduced, from now on, let me explain the new feature regarding SQL files or synchron files, which is Delta table replication into SAP HANA Cloud. So basically, as Rob already explained, we have supported the direct on-the-fly virtual table access to a Delta table, which can be stored in object storage or which can be accessed through Databricks Delta sharing. So in both cases, we introduced two adapters. One is file adapter and Delta sharing adapter. And from QRC 04 this year, for those two adapters, we are happy to introduce a new capability, which is about replicating data into SAP HANA Cloud. So which is based on the remote subscription interface, which is, I believe you are familiar with the HANA to HANA data table replication or SDI table replication. So we use the same interface, remote subscription. And here we support two ways of initial load and two ways of change data capture. So when it comes to the initial load, you can load the data in a chunk-based approach, which is quite useful when loading vast volume of data into HANA Cloud, so that you can divide the large volume of initial load into multiple chunks and loading them one by one. Or you can simply, if the loading data, the size of the data to load is small, then you can just go with the one-step initial load. Once the initial load is done, then the next step can be change data capture. So here we also offer two options. One is user-driven CDC change data capture, which is based on the Delta table version. So Delta load as a version, that's the one option. Another is based on our internal job scheduler. You can configure the scheduled CDC, which is distributed with interval seconds. I will show you the detail in the demo. And so you can choose either one of these initial load, then also choose either one of these CDC ways. So any combination can be done. Chunk-based initial load, then scheduled CDC, or one-step initial load, then user-driven CDC, or scheduled CDC, and so on. So, and one important point I would like to introduce is it offers both column-wise and row-wise sub-table replication with a subquery, and also you allow the source side schema changes, but it is about adding columns only. And in addition to the normal load behavior, we offer offset load behavior with 3 additional metadata columns. One is type, which indicates the insert, update, delete, or last process time, which is a timestamp, and also corresponding Delta table version. So these are the new capabilities with this new Delta table replication into SAP HANA Cloud. And in addition to the remote subscription interface, we also offer 2 new interfaces. One is a Fabric virtual table, which is already available for other remote sources, but with Delta to HANA replication, you can also toggle virtual table into a replica by adding a system-owned replica or user-owned replica using this command line, and also this SQL statement. And also you can here define the refresh interval when it comes to the CDC. In the UI side, we also introduced a new tile here for the existing data replication app in HANA Cloud Center. So let me show you a quick demo from now on. So here is my Databricks. So let me show you quickly select the data. So here I select data from the orders table, and also I will select the data from the customer table. So here is data, as you can see. And if I run here, you can see that this amount of records are stored in this delta table, which is shared via delta sharing. And here is another table, customers table, and here you can see some data inside in it. So with this, let me go to the HANA Cloud Center console here, and let me run this query here. So this virtual table I already created is pointing to that orders table in delta table stored in via delta sharing. So as you can see, all records are retrieved correctly. And with this, like the HANA to HANA table replication, you can create a replica table using the virtual table like this. And here you can create a remote subscription like HANA to HANA table replication or SDI. And here I use the 10 megabyte as a chunk size, while the default is if you doesn't define the chunk size, then it is 100 megabyte, but here I use the 10. And if I check the chunks in this monitoring view, then as you can see, there are 3 chunks are defined based on the size. So there are 3 chunks, 1, 2, 3, and size, and the status is prepared now. So I can load the chunk one by one, or maybe I can load them two of them together for here. So here I load the chunk 1 and 2 together. So it will load the first and second chunk. So if I check the monitoring view again, then it will show you the those 2 chunks are already loaded. In this way, you can divide the large volume of data. When you load the large volume of data into HANA Cloud, you can divide the data into chunk and handle it in an easier way. And so after that, let me load the final chunk here, chunk ID 3, and the next step is the finalize the initial load. Once the initial load is done, then already the replica table has full data in it. So if I retrieve data in the replica table, it shows all data is correctly replicated. And then if needed, you can define the change data capture in this way. So default value is 1 hour, 3,600 seconds, but let me use the 30 minutes here. And one important point I would like to mention is to use this scheduled CDC, the enable change data feed property must be set on the source data delta table side. And once it is set, then if I check the schedule, then as you can see here, the first run is already completed, and the next run is planned 30 minutes later. And that's it all about the replication. And if needed, you can also use a subquery when create a remote subscription to filter out row-wise or column-wise. And if needed, you can, if you need, then you can start off from the initial load by using this reset command, or if needed, you can drop the subscription to make the replica table as a normal table. So that's about the remote subscription interface, and the Fabric virtual table case is similar, but here I can directly, so let me skip the Fabric virtual table due to time constraint. But anyhow, you can use this way to toggle the virtual table into a replica so that the data can be retrieved from the replica table. And due to time constraint, let me quickly show you the UI first. Here in HANA Cloud Center, you can choose the data replication UI. And here you can choose the existing remote source, or you can create a new one from here. But if I click the existing one and next step, then you can choose the tables to replicate, which can be retrieved from the data sharing. So I can choose orders and customer. And if I choose customer as just initial load or orders for the real-time replication and confirm it. So in that step, it easily initialize the replication or initial load here. But due to, as it is a simplified way, there are some limitations, which means not all full capabilities are not supported here, like defining time interval or subtable replication and so on. So basically that's it, and more details will be found in my blog later. So please visit my blog later, and that's it or from my end. And let me hand back to Andrea for closing.
Thank you very much, Jun. As we are on top of the hour, let me just share a few additional information with you. As I said before, since the time is limited, we cannot cover the full scope of our innovations, but you should definitely check out the technical documentation and the upcoming What's New blog post. And don't forget to follow us in the SAP community, as our product management team regularly publishes all the blog posts in there using the hashtag What's New in SAP HANA Cloud. And with that, I want to thank all of our speakers for sharing these great insights into some of our Q4 2025 innovations. And we have reached the end of today's webinar. Thank you very much for joining us, and stay tuned.